Section 10.1. All right, Theorem 10.1 is the area of a rectangle. So keep in mind that the area of a rectangle is just base times height. The base and the height for a rectangle should meet at a right angle, so you could use any combination of these heights and bases that meet at right angles. 10.2 is the area of a parallelogram, which is also base times height. And for a parallelogram, you'll have a base, and then you need to find a perpendicular measurement to that, and that becomes your height. Very important here. Remember that the altitude is from a vertex and is perpendicular line opposite the side. So an altitude is another way of saying height. So an altitude is the height. And an altitude must be perpendicular. So here we have some practice problems. It says finding the area of a parallelogram. So in question 1, we have this 5-inch line here, which we'll say is the base. To find the height, we find a measurement perpendicular to it, which would be this altitude here. So we have our base and our height. So we'll just set up our formula for the area of the parallelogram. Area equals base times height. In this case, 5 times 4 is going to give us an area of 20 inches squared. And the inches squared is the unit for area. Question 2, same idea. We have this perpendicular measurement here, which is 3.5, but it falls outside of the parallelogram itself. But it actually corresponds to this base here. So these are the two measurements we want to use to find the area of this parallelogram. So area in this case is going to equal our base times our height. So 2 times 3.5 gives us an area equal to 7 centimeters squared. Question 3, what is the area of a parallelogram with a base length of 12 meters and a height of 9? So 12 and 9 are our base and height. So area equals 12 times 9, which in this case is going to give us 108 meters squared. When working with parallelograms, sometimes it becomes necessary to find a missing dimension, such as your height. In these two cases, we have a set of bases and a set of heights that should correspond, and, well, we have one set of base and height and one base, and we have to find the additional height for the other base. So in question 1, if we look at the measurements carefully, we've got this base here, and its corresponding height would be this line here, but there is no particular height given for this. So we'll make this our variable x. Then we have this length here, which could be our height that corresponds to this base. So what we want to do is we want to use, and I'll kind of change the color here, we'll use this base and this height to find the area of this parallelogram. And so in this case, the area of this parallelogram is 117 inches squared. Then we take the area, so we know it's 117, and we set it equal to the other base and the other height that we don't know. So instead of x, let's use h here. And so we've got 9.4 times h, and then we're going to solve this for h. So we would divide by 9.4, and we get that the height that we don't know in this case, or if we want to more accurately, we'll call it DE, has a length of 12.45 inches. Question 2, we do the same thing. Well, we should recognize that we've got this height that corresponds to this particular base, but we don't have the actual measurement of this height, so we don't know what this is. But we do have a height here that is 10 centimeters that would correspond to the side that is 9. Because if this is 9, this is 9 as well. So we'll use those two. So we'll use the 10 and the 9 to find the area. So area equals 9 times 10. So our area is 90 centimeters squared. Then we take the area, which is 90, and we set it equal to, in this case, the base, which is 12, times the height, in this case, that we're looking for. Then we just solve this. So we divide both sides by 12, and we get that height, or in this case, we want to call it length df, is equal to 7.5 centimeters. The area of a triangle is half the product of the base and the corresponding height. So area equals 1/2 base times height. And once again, keep in mind your heights have to be given in perpendicular measurements. So for our first example here, we've got 16 centimeters and 12 centimeters are our given items here. So we've got a base and we've got a height. So we've got area equals 1/2 our base times our height. So in this case, our area is just 96 centimeters squared. Question 2, we've got essentially a height here and a base here. And we know this because they make a right angle, which is perpendicular. But notice they're in different units. So we might want to change the 1 foot here into 12 inches. And so now to find our area, we're going to take 1/2 the base, which is 12, times the height, which is 5. And our area in this case is just 30 inches squared. Here we're talking about finding the area of an irregular figure. And it says, what is the area of the figure? So all we're going to do is we're going to use the properties we already have, either the area of a triangle added with the area of a rectangle, and so on. So for example 1, we can find the area of the triangle here. The area of the triangle is 1/2 base. So in this case, the base is a part of the square, so the base is 6. The height being perpendicular to it would be 8. So the area of that particular triangle piece is just 24. In this case, inches squared. Then we're going to find the area of the square, which is base times height, or side squared. So that'd be 6 times 6, which in this case would be 36 inches squared. And so the last thing we need to do is add the two measurements together. So we're going to take these two and add them together, and you get that the total area is 60 inches squared. Question 2, very similarly, we're going to go ahead and find the area of the triangle. So the area of the triangle is 1/2 the base. Well, the base of the triangle is this piece here. If both of these measurements are 3, so that's 6, we take 6 away from 15, we get that the base is actually 9. And then the height would be this measurement here. Well, it's a part of this 11 measurement, but we don't include the 5 inches here, so the height must clearly be 6. So 1/2 9 times 6 gives us an area of 27 inches squared. Then we're going to find the area of the square, or sorry, the rectangle. The area of the rectangle. So area of a rectangle, base times height, so that's just 5 times 15, which gives us an area of 75 inches squared. Then the last step here would be to bring them together or add them. So we take this plus this, and we're going to get that the area in this case is 102 inches squared. All right, go ahead and pause the video, try question 3 on your own, and when you're ready to see the answer, unpause it. So in question 3, you should have gotten that the area of the triangle is 10 centimeters squared, the area of the rectangle is 60 centimeters squared, and the area total is 70 centimeters squared.